OpenCV in artificial intelligence and computer vision. AI intermediate level. Introduction. Many artificial intelligence systems need to analyze images and videos. Examples include detecting objects in camera feeds, recognizing faces, tracking motion, reading text from images, analyzing medical scans. To perform these tasks, developers use powerful computer vision libraries. One of the most widely used libraries for image and video processing is OpenCV. OpenCV provides tools for image processing, video analysis, object detection, facial recognition, feature detection. It is widely used in fields such as robotics, surveillance systems, augmented reality, autonomous vehicles, medical imaging. Understanding OpenCV is important for building practical computer vision applications. What is OpenCV? OpenCV, Open Source Computer Vision Library, is an open-source library used for computer vision and image processing. In simple terms, OpenCV equals a library that helps computers analyze images and videos. Example concept. Image, video means OpenCV means visual analysis. OpenCV provides hundreds of functions for analyzing visual data. It supports multiple programming languages such as Python, C++, Java. Why OpenCV is important? Images and videos contain large amounts of visual information. Analyzing this data manually would be extremely difficult. OpenCV helps developers process visual data efficiently. Example concept. Camera feed means OpenCV processing means detected objects. OpenCV enables applications such as real-time video analysis, automated surveillance, image recognition systems, robotics vision systems. Key features of OpenCV. OpenCV provides many powerful computer vision features. Major capabilities include image processing, video processing, object detection, feature detection, machine learning tools. These features allow developers to build advanced vision systems. Image processing. Image processing involves modifying and analyzing images. OpenCV supports operations such as resizing images, rotating images, cropping images, filtering images. Example concept. Raw image means image processing means enhanced image. These techniques help improve image quality for further analysis. Edge detection. Edge detection identifies boundaries between objects in an image. Example concept. Image means edge detection means object outlines. Edges help AI systems detect shapes and structures. OpenCV includes algorithms such as canny edge detection, Sobel filter, Laplacian filter. These methods highlight important visual features. Object detection. OpenCV can detect objects in images and videos. Example concept. Image means OpenCV detection means object location. Object detection is used for pedestrian detection, vehicle detection, face detection, product detection. OpenCV integrates with deep learning models for improved detection accuracy. Face detection. OpenCV includes built-in methods for detecting faces. Example concept. Image means OpenCV face detector means detected face region. Traditional face detection methods include HAR cascade classifiers, local binary patterns, LBP. These methods quickly locate faces in images. Video processing. OpenCV also supports video analysis. Example concept. Video stream means frame extraction means computer vision analysis. Applications include motion detection, object tracking, surveillance systems, activity recognition. OpenCV can process video frames in real time. Feature detection. Feature detection identifies unique points in images. Examples include corners, edges, texture patterns. Example concept. Image means feature detection means keypoints. Popular feature detection algorithms include SIFT, Scale Invariant Feature Transform, SURF, Speeded Up Robust Features, ORB, Oriented Fast and Rotated Brief. These features help match images and track objects. OpenCV workflow. A typical OpenCV workflow looks like this. Load image or video. Down pointing arrow. Pre-process image. Down pointing arrow. Detect features or objects. Down pointing arrow. Analyze results. Down pointing arrow. Display or store output. This workflow enables many computer vision applications. Example Python code. OpenCV is commonly used with Python. Example code. Import CV2. Hash load image. Image equals CV2, imred. Image.jpg. Hash convert to grayscale. Gray equals CV2, CVT color. Image. CV2. Color underscore BGR2 GRAY. Hash display image. CV2, IM show. Image. Gray. CV2. Wait key. 0. This simple program loads and processes an image using OpenCV. Real-world applications of OpenCV. OpenCV is used in many industries. Security systems. Face detection and surveillance monitoring. Autonomous vehicles. Detecting pedestrians. Traffic signs. And vehicles. Robotics. Helping robots understand their environment. Healthcare. Analyzing medical images such as X-rays and MRIs. Augmented reality. Overlaying digital objects on real-world images. Advantages of OpenCV. OpenCV offers several advantages. Advantages include open source and free, supports multiple programming languages, real-time image processing, large developer community. Example concept. OpenCV tools means faster computer vision development. These benefits make OpenCV one of the most widely used vision libraries. Challenges of using OpenCV. Despite its power, OpenCV also has some challenges. Challenges include steep learning curve for beginners, complex APIs for advanced features, heavy computation for large images. Example concept. High-resolution images means increased processing time. Developers often combine OpenCV with deep learning frameworks for advanced applications. Concepts learned from OpenCV. Understanding OpenCV helps learners understand. Checkmark how computers process images and videos. Checkmark how object detection systems are built. Checkmark how real-time video analysis works. Checkmark how computer vision algorithms detect patterns. Checkmark how AI vision systems are implemented in real applications. OpenCV is one of the most important tools for building computer vision applications. Simple definition. OpenCV. An open-source computer vision library used for image processing, video analysis, and object detection. Final summary. OpenCV is a powerful open-source library used for computer vision and image processing. It provides tools for analyzing images and videos, detecting objects, identifying faces, and extracting visual features. Because of its speed and flexibility, OpenCV is widely used in robotics, surveillance systems, healthcare, and autonomous vehicles. By combining OpenCV with machine learning and deep learning frameworks, developers can build intelligent systems capable of understanding visual data. Understanding OpenCV is essential for developing real-world computer vision applications.